In this video, we're going to go over some properties of real numbers, which is really algebraic properties that we need to sort of know in order to do algebra. Um, so let's start with the commutative property. Okay, so we could think of this as simple, but it's actually more powerful than you think. And if you want to know why, I'll give you an example of why it's nice to use the commutative property sometimes, okay? And there's actually sort of a meta-commutative property where we can kind of flip equations in the same way. So, for instance, we have x plus 9, right? So what they're really asking in this problem is what's another way to write that? And because we know addition is commutative, we can flip that. So another way would be to write that as 9 plus x, okay? Now that might not seem like that important, but it really is. And I'll show you in a second. So this is the right answer, 9 plus x, okay? But think of it this way. When would we want to use this? Well, particularly when we have negative numbers, right? So sometimes you're going to have problems where it's like, maybe it's negative 9 plus x equals 17. And the way that's written, it's not so obvious what to do, right? But we know that even with the negative, this is still commutative. So we could rewrite this as x. Instead of putting plus negative 9, we just put minus 9 equals 17. So really what we're doing is we're moving this and this. They're flipping spots. The x goes over here, the negative 9 goes over here. So we have x minus 9 equals 17. And so when we're asked to solve things later on, we can see what to do. So we're just going to add 9 to both sides and get x is 26, okay? So that's an example of the commutative property and why we use it. Let me show you a couple other ones. It's also multiplicative. This is not maybe as important with numbers, but it certainly is with variables and how we are able to move things around. So we have c times 2, and this question is just asking, since multiplications is commutative, what can we do? We can flip it, get 2c. Okay, so that answer is just 2c. Okay. Not as important, the associative property, but let's talk about it. It's pretty straightforward. It certainly would help when we were dealing with order of operations, so maybe that's a reason to justify knowing about this. But we can say that this is the same as x plus 29 plus c. Okay, because the parentheses aren't really there, so we really have this. So really what we're saying is, and this might, I don't think any other person would teach it this way, is another way of thinking of the associative property is that we can kind of insert parentheses and get rid of them. I think that's more important because it kind of can allow us to work on things, right? Because according to PEMDAS, if we had this, what should we do first? We should do whatever's inside here. Whereas according to this, we would do that. So, um, so it is an interesting property. So it also helps with how we enter things into calculators. And let's talk about distributive, and then we're done, okay? So we have an A out here and a Q inside -8. All right. There's nothing we can do inside. Even though PEMDAS says do what's inside parentheses, we can't do anything. What the distributive property is really just reverse factoring. It's asking if we factored an A out, what did we have? Okay. So think of it this way. If I gave you what we would get, could you see this? Right? If I said, hey, here's your problem right here, what would you factor out? Well, they both have an A in common, okay? So if we took an A out, we would get this. So distribution is sort of reverse factoring. But what we do is we'd say this A gets multiplied by the Q, this A gets multiplied by the -8, and we would get AQ minus, we could put A8, but it's a little easier to write 8A. Okay, so if we had A8 using the commutative property, we could flip it. All right. I think that's all I want to go over in this video. Um, Negatives are tricky, but I'll leave that for a different video.